Okay, welcome back. So there are several questions people have. I'll quickly answer them and then get on to the other topics and some more exercise problems for you. How to find other existing? So the first question I'll answer is, how do you find other existing modules like math module? Well, you can't quite find them that easily, in the sense that you can't do a find or something like that. The best way is, if you have installed any new packages, you know what you have installed. But by default, if you want to find out the standard library, there is excellent documentation available at the python.org. I'll show you the page, docs.python.org. Okay. Unfortunately, the network for me is down. I am not able to show you that, so I'll write out the link here. Okay, it's a standard place where you get plenty of documentation on Python. There's a full-fledged Python tutorial and information on all the standard library packages. From there you can find, you can even search there and you'll be able to find what you can do. Okay. Is there any test today? I think we will have one more little test today. Then we'll give you some assignments for the week. Next question, how can we import package from other directory than from current directory? Unless you install the package, there is no way you can import it in some arbitrary directory. You have explicitly to cd into that directory if you really need to do it. Okay. So typically, when you are creating many modules, the general approach that you follow is, you create a package hierarchy, or you create a set of modules in a current directory, and then eventually you install it so that other people are able to do it. But unfortunately, this is a little more complicated. It's a little too advanced for me to introduce at this stage. Okay. But there is a mechanism by which you can install Python modules on the system, and I am not discussing that right now. Third question, is there any command for exporting and importing the history of commands worked in IPython? It's a very good question. So there is this command called %hist. We usually cover it in the advanced sections. Next week you will be looking at it. But %hist so %hist or history, basically it prints out the input and output history for all of your the input history for all of your commands typed so far. So let's try it, %hist. Okay, and now it gives me the line numbers. If you don't want them, you say -n. It will tell you all of the lines. These question mark commands are not legal Python, and therefore they will not be executable lines of code. Everything else is actually legal lines of code. Okay. But all of these IP magic things are all IPython specific, so don't rely on them. But supposing I am typing print hello, notice that I will get the print hello word. Okay. Depending on your version of IPython, behavior may be slightly different, but the hist command, %hist, will allow you to look at the lines of code. There is another command called save. This will allow you to save a set of lines. Remember that every line of yours is numbered in 1, in 2, in 3, in 4. So you can always create a file by saying save line 1, line 3, line 5, so on and so forth. So look at the options, and this will be covered in greater detail next week, but there are commands to do this. Third question, please repeat creation of user defined modules. I spent so much time on this. Well, all you need to do is simple. Create a .py file, make sure that the name of the file is a valid variable name. That is, it's an alphanumeric, not starting with a number, starting with an alphabetical character. It is case sensitive. So basically alphanumeric with underscores, no dots, no periods. So basically it should be, so if you want to say module foo bar, so it will be foo underscore bar dot py. Create a file like that. Then you can import that as, okay, or hello world dot py can be the module name. Then I can say import hello world. That's all. So basically create a file .py file with a valid variable name as the name, the base name of the file. Say whatever Python code you want inside that, you should be able to import it. That is a Python module. That's all there is to it. Okay. The only other thing you have to remember is any code inside that is going to be executed. So most often your modules will contain various functions and things like that. Okay. Now you may not want it to execute any code and print anything at the time, in which case you have to do all this name gymnastics. You have to say check the value of name. If name is main, you can print something. If the name is not main, it will not print anything. So if you need to print anything when it is running as a Python module, or rather when it is imported, you don't want to print it, then you put anything inside the main. But if you want to print, when I run it like an executable, if I say Python hello world, you put it inside if main. That's all. Okay. So the name variable is local to every module and is equal to main only when the file is run as a script. That's the only thing you need to remember, this last line. So if you want to run a script and produce output, it is a good idea to put that inside an if underscore underscore name equals underscore underscore main dunder. Okay. And typically people will call double underscore as dunder. So you say dunder init dunder, because it's easier to pronounce it saying double underscore, they call it dunder. Or dunder main dunder means 2 underscores main 2 underscores. Okay. Next question, how to run Python on Windows? Well, there are plenty of solutions, at least 2 that I am aware of. There are actually 3. You can just download the Python executable, install it, you're done. There is another package called Python XY, which is free. There is yet another package called EPD, Nthought Python distribution, which is an excellent Python distribution, but it's free for use by educational institutes. It's not free for commercial entities. So you can download it, install it, and you have Python. So all of those options are available. Please list editors and links. Well, there are plenty of editors and plenty of links. I think you can find them out for yourselves by using Google. I will not directly recommend any of them in particular because there are so many editors. There is Eclipse, there is Vim, there is Emacs, there is Spider, there are several. And if you search on Google, you will get many hits. And I would suggest you learn something like Vim or Emacs because they are generally useful to know. So maybe Vim or something like that you can use and configure it to use it with Python. Okay, so let's get back to basic Python. So here's our little module fib that now returns fib of 100. Okay. So what I want to look at next is take a few more little problems and look at something called test-driven development in little more detail. Okay, so we'll get back to the slides in a little while, but what we'll do is we'll take a simple problem and I'll try to motivate for you the use, how do you use tests, why do you use tests, and how to do all of this test-driven development. How do you become a better programmer? I'll take it later. So what we'll do now is we'll take a few simple problems. And I remember that I said I'll solve one particular problem again by looking at it a little closer. So the problem we will consider is, again, let us look at this Fibonacci sequence itself. Okay, we wrote this function, and I want to now see how I can use a process or a workflow by which I am able to write this code and make sure I am not making too many mistakes. Okay. So first thing is, we already wrote this Fibonacci, right? Let me just make some unnecessary mistake. Imagine this is a typographical error. Somehow I accidentally made this mistake. I don't know, or I said is so I have made this mistake. How do I now? So imagine you are starting to write this application. You are starting to write this Fibonacci function, and you don't have it correct. It's wrong. Remember, we were trying to count the number of words in a file, and we wanted to deal with punctuation and all of those cases. How do we now solve that problem? So the first thing, if you remember, was I said you first think of, the function you have to write, and now you need to think of the corner cases. To know, you have to check, right? The function does something, I want to make sure, yes, this function is correct. So firstly, what is the answer? If I give you fib of n, what should I get? So fib of, say, 5, or fib of 2 should give me what? What should I expect? It should return a list 0, 1, 1, correct? Why? Because it should print the Fibonacci sequence until it hits 2 and before that. So if 2 is hit, it should not print that 2, right? While current is less than n is the condition. This is what I expect, right? So let us see what I get. If I do fib of 2, what happens? First I have to import fib, or better still, let me do %run fib. What's happened? It's gone into an infinite loop. It didn't even get out. Correct? What happened? So let me do it again. It's not even returning. So I can't even make a function call. I can't even import that module because it's gone. Okay, let me import it and see what happens. Import fib. This worked because I have not called the function. When I run it, it will execute the fib inside main, right? But when I import it, it's not, because I have carefully put the fib inside the main. Notice, only when name is main is it going to do fib. So if I run it, it will run that code. If I don't, it won't, which is nice. Now let me do fib.fib 2. Gone, infinite loop. So to get out, I press Ctrl C, it will get out. What do I do? So I go back, debug, and said, oh, I made a mistake, current should be next. Now import won't work, I have to reload. So let us just run fib again. Now it works. Okay, reload fib. Now when I do a run, the fib module is available, the fib function is available locally, because it actually runs that and gives me that contents of the namespace that is there. I think some of you may have been confused. There are two things going on here. When I do %run, IPython will execute fib, find out the namespace, and put it back into the current namespace. So when I do run fib, it ran the file, but it also makes the fib function available. Okay, and now if I do, for example, import fib, How do you view and modify PyCode on prompt? Use Vim, use an editor. One of the questions is how do you view and modify a .py file on the prompt? Use an editor, any editor, gedit, Kyle, Vim, Emacs, Eclipse, whatever you want. Any good text editor. Don't use Microsoft Word or something like that to edit it. That's not a programming editor. Okay, so now fib is available. So I say fib of 2 gave me 1 1. It should give me 0 1 1. Correct? Now I make a mistake again. So now problem is, if I check for it now, I have only checked for it once. 2 days later if I come back, make some mistakes, I don't know which tests to run. I don't know which cases I gave as input, what is correct, what is wrong. So with test driven development, what you do is, you write what are called test functions. Okay, so now I'll write one more function called test underscore fib. Now inside this I can call fib, right? So I'll say result equals fib of 2. Correct? Now if result equals 0, 1, 1, print OK, else very simple. Okay. Now instead of doing this print business here, I will simply run. So what am I doing? I just wrote another function which will call fib with an argument that I know 2, for which I expect the answer to be 0 1 1. Correct? Is this clear to everyone? Now all I do is I will say run. Says error. Unfortunately, it doesn't tell me more than that. It simply says there is an error. Okay. So what can I do? I can say okay. So I am saying I expect the first, I got the second. Now let us run this. So I expected 0 1 1, the result I actually got was 1 1. Now I also know what the error is. So now I can go back. So this is a very, very rudimentary simple test. But notice that I am doing this okay. So now if I want to say, no, I want to now test fib of 300. I will have to write all this again. If result is this, do this. Okay. So one way of doing it is to make that into another function, then call this function and then print out the necessary message. It turns out Python has a very simple, convenient way of doing this. It's called asserts. You use what are called assert statements. So I can say assert, it's a keyword, result equals 0 1 1. Okay. Now I will delete all of this. Notice that the code is much simpler. Now it tells me assertion error, warning, failure executing file. Okay. Now one convenience of IPython is that it has something called PDB mode, the Python debugger mode. So what you can do is, at this stage you can use the debugger if you want, but better still, you need to figure out what this result is. Right? So the nice thing about PDB is, well, the difficult thing is I'll have to introduce you to PDB, show you what you can do. But instead, one simple thing you can try is, you know that you got an error at this line. How? Because it says line number 14, look at this, it's saying home IITB fib.py. Notice this line, it's pointing to you specifically saying line number 14, assert result is wrong. So now I know which line is failing. I can go back here. What is the result I got? 1, 1. Okay. So the nice thing about this test is, now this test is permanently there. It is in the same file, which means in the future if someone was to run this, they know, oh, this code should satisfy all of these tests. Okay. So now let's flesh this out, let's correct it. I'm correcting the code. Notice that it didn't give me any errors because the code is correct. So I just run it, no errors means everything is fine, everything passed. Okay. But now I say, okay, I want to test something else. I can say assert fib of 0 should be what? Fib of 0 should give me empty. Then assert fib of 1 should be 0. Correct? 2 new test cases I have created, passes. So it looks like my code is correct. Let's try something slightly more complicated. So if it passes all of this, I am pretty certain my Fibonacci function is correct. Now I can call fib with some crazy argument and I know it will produce the right output. Okay. So this is what you typically call as test driven development. Well, there is a little bit more to test driven development. When test driven development, you will actually write the test first and then you will write the actual code, but I won't stress on that too much. The general idea is, you write reusable small pieces of code like the one I have talked about here, and you write a little test function to make sure that this code is executing correctly. And what we use is asserts, okay, in order to do this. Now this is the beginning of test driven development. The instant you start doing this, most 80 to 90% of your test driven development is actually over. The rest is a set of tools that you use to make this more easy and automatic. Okay. So there are some slides here about some other tools that are used to write tests. I am not going to get into those tools. I will use only one particular tool to illustrate how you can use test driven development tools to write nice code using tests. Okay. And as an exercise, we will use all that we have learned to solve one more problem now, okay, in about 5 minutes. So how do you do test driven development? The basic idea is, decide upon the feature to implement and the methodology of testing it. Write the tests for the feature that you have decided upon. Write enough code so that the test can run but it fails. Improve the code to just pass the test. At the same time, passing all previous tests. Run the test to see that all of them run successfully. Refactor the code, so on and so forth. Go back to 1. So the idea is, you write your tests, write the code, the feature. First the test is going to fail because the feature doesn't do anything yet. Implement the feature, make the test pass, make sure no other tests fail, and now once all the tests have passed, your new tests have passed, your code should be functional. Okay. So that is test driven development. Perhaps it is a little too formal right now. And at this stage, you may not understand or appreciate the value of this, but it's an extremely important process that is useful to follow. So this is a simple example. Again, I went through the same example in the context of our Fibonacci sequence. Okay. This is just the same thing with a different approach of using the GCD function instead. The same idea. The idea is you have the test code, you want to check whether GCD of 48 and 64 is 16. If it is not 16, you print out a big message. I have automated all of that by using these 4 or 5 lines of code. Okay. So now they are slowly systematically going through that process. You create the file, create the feature, create the function. Okay. Nose tests. So there is this package called nose, which makes it extremely easy to run tests like the kind that I have defined. These tests, as you can see, are very easy to write. It simply requires, if you switch to the terminal, so if you look at this, I mean, these are fairly simple to write. It's just a few lines of code, and almost the same code you would have written when you are testing your code. You would have done fib of 5, you would have seen the values. The only thing you have done here is you have put this assert and you have compared it with the actual result. So you have essentially, so what this nose module does is, there is this function, there is this command called nose tests. You just run nose tests on your module. It will run the module, run all of the test star functions, check that the output is correct. Okay. So what we will do is we will use nose in order to do this testing. So let me just edit this file and make a mistake. Let me go back and make the mistake of 1, 1. Now if I run this file, it will say it failed. There was an assertion error. I expected result is this, but I didn't get it. Now nose test has a bunch of additional options. I can say nose test minus help. It gives me plenty of options. Okay. Perhaps the most useful, supposing I run nose test minus d fib.py, it will give me detailed errors. So it is basically saying fib of 2 actually produced 1, 1, and 1, 1 is not equal to 0, 1, 1. So as you can see, I don't have to do any additional work. I just do nose test minus d fib.py. It actually tells me, oh, you wanted this, you got this, they are not the same. And I don't have to do inspection, debugging, print statement, nothing. I just do nose test minus d, it says, oh, fib of 2 is returning 1, 1. Does this make sense? This line is basically the result, this was the actual error, that is the line of code that was failing. It is expanding on that and telling me that this is the detailed error, saying that fib of 2 is actually 1, 1. And it asserts that 1, 1 is equal to 0, 1, 1, which is not true. Therefore, it is failing. So now I can go inside, edit it, and fix it. Now it says everything ran, no problem. Notice that it says ran one test and saying OK. So now that you understand the basics of testing, let us put it into practice. Shall I repeat? I will repeat myself one more time on how you do this. First, what you do is, we will take a simple problem. Okay, I will write one more function now for you. Let us solve the solution to one of the problems that you had solved during your test, which was factorial. So I have created a file called fact.py. So I will first define the function fact. Okay, this is what I want to create. I want a function called fact, given an argument n, and I will give it the documentation string. Now I will not finish this, I will just put pass here and I will write the test case. So what should I find now? First assert fact of, so give me something, give me a test case. So this is where you have to think of all the corner cases. Fact of what? Huh? Fact of 0, right? What should factorial of 0 be? Should be 1. Assert factorial of 1 should be also 1. Assert factorial of what should 5 be? This should be enough, right? So if my factorial passes all this, I am super happy. So how do I test this? Well, let me create another terminal. So now we run no stress fact. It failed. Okay. Obviously, it is going to fail because I did not write anything. I just said pass. So let us write our first attempt. Return what? Okay, very happy. So this fellow gets a failure. It says maximum recursion depth exceeded. Okay, so that is, it kept recursing and it died. Essentially, it went into an infinite loop. Why? I forgot the escape clause. Everything works. But how about will this work? It may not work. I don't know the answer. So at least this function call should return, correct? There should be no error when running this. So it's simple for me. I just add one more assert and said, okay, I don't know what the value is. It should be some positive value. Okay. Error. So basically, Python has a recursion limit. You can't recurse infinitely because it has a finite size stack. Okay. So if you want to really write a good factorial, you should not write a recursive one. So now comes the power of tests. If I want to change the implementation, in the past, I will have to again go and say fact of 0 is 1, fact of 1 is 1, fact of 2 is 2, fact of 6, because accidentally it may work for that one case that you are testing. Whereas now I have all these 5 cases, I don't have to type 5 lines, I just do no stress and I know it's run, correct? So the point of good testing is once you write it, you are finished. Next time you can refactor it, change the implementation, optimize it, implement it in C, in for whatever you want you can do. So long as you can call that one function called fact. Does this make sense? So now you can imagine if you have a large application and you want to make sure everything works. You change one small bit here, everything breaks. You don't want to have these things happen. So now let us rewrite this in a non-recursive solution. How do we do it? How do you get the factorial of a number? N into n minus 1 into so on and so forth, right? So can I use a while loop? Right? So first I say I must first initialize some quantities. I need a counter. I say count, counter equals n. Okay. One thing you might want to do here is you may want to say if n is less than 0, what should you do? Or should I raise an error? I should actually say there is some mistake, something is wrong. So let us use the same strategy. We will say assert. It will basically say assertion error. So if this quantity is true here, n is greater than 0, it will be fine. But if quantity is not greater than 0, it will say I am sorry, or greater than equal to 0. Okay, but that is fine. Now we define a counter and we want a result. I will call it f as the factorial. F is equal to 1 while counter greater than 1 f will this work? Well, I do not care, I can always try. Now that is the beauty of having tests. Unfortunately, the factorial number that I have given here is too large. This factorial will be enormous, which is why it is taking so long to run. But the previous code did not even get so far, correct? So let me put it out of its misery. Okay. Look, where is it failed? It is failing here. It is not failing, it is basically taking forever. So let's make it, let's remove this and make sure the rest of it works. It works. So our implementation is correct, but our test is actually a nasty test. So let me make it smaller. Even this is a large number, by the way. This will also be extremely large. Hopefully it should finish. Okay, we can wait for it. In the meantime, I could even consider writing a separate solution. So I can say, okay, I don't want to do it with a while loop, I want to do it with a for loop. That also can be done. Correct? So I could say f is equal to 1. The mistake here is subtle. Range of n will not end at n. So I have to do n plus 1. But well, we will be lazy, we will expect nose test to find out. Well, even this is taking very long to compute. Because let us try if this works at all. Assert fact of 1 is not 1. There is one more problem in my implementation. I starts at 0. So 0 multiplied by anything, the answer will always be 0. So I need to say 1 to n. Now let us see. Failures. Fact of 2 should be 2. So why is this giving an error? Okay, saying fact of 2 is 2. It has not given me the value. It is not 2. So basically, I need to change n to n plus 1. Everything runs. And in fact, this test also works. Increasing it by one order of magnitude is too much. Okay. So as you can see, I have written 3 different solutions to the same problem. I only wrote my tests once. So very often you will feel it's a pain for me to write these tests. It's not. You would have written these 5-6 lines anyway when you are trying out the function first time. All I am asking you to do is write those functions and put them in a separate test case, and you should be good to go. Okay? So this is the heart of test driven development. The idea is you write a little test which collects all of the corner cases you are talking about, put them in a test underscore something function like what is seen here, test fact, give that function that you are going to write or whatever you are going to write arguments for which you know the correct answer, test if that works. That is the only way you are able to assert that the function actually works or does its job. So supposing you are building a car, okay, how do you know this car is going to perform? Because you actually perform tests. Many engineers do this. Unfortunately, as software engineers, we don't do any of this. We just write programs, cross our fingers and hope that it will work. That's the worst way to write programs. If I even build this chair, we won't be sitting in this room if we didn't do some engineering testing. We'll always do engineering. We'll say, okay, what is the size of the thing so that the load will be calculated. You will calculate the load. You will build a solution. Then you will test that solution by trying to break it. You will over design it by making sure that the weight, the size of the truss, the size of all of the members that you use is large enough, and then only you will sell it. If not, you may kill somebody. Okay? So generally in engineering we tend to do this. However, in software engineering, many people seem to be very lax. When they write their code, even research codes, there will be no tests. The code will barely run. It will produce some numbers. No one knows whether numbers are actually meaningful or they are garbage. And the worst part is, very often you will get garbage and you will not know that it is garbage. You will get nice looking pictures. Oh, this plot looks beautiful. But ultimately there will be some sign mistake. There will be some stupid mistake. We will still get the right answers, but it's actually wrong. So if you write tests systematically and you make sure every function is doing the right thing, you will ensure that your code quality is very good. So it's a very good practice, and as I have shown you, it's not very difficult. So what I am going to do now is going to give you a little exercise. So let's solve this one problem. Create a file called WordFreak. Okay. The problem statement is this is your problem statement. I will give you 15 minutes, write tests and write the function and show that you are able to write this test driven kind of code approach. If you do not have nose installed, simply create an if name equals main, call your test function. The assert errors will still be produced. Okay? So first call the function, let's call it now. If you don't have nose installed, you can just do if now please write the test. Some of you are saying that we have done it very fast. Well, I have repeated myself, and actually the concepts are very simple. Write a function. You will write two functions. I have introduced one new concept called assert and one new tool called nose tests. So you simply say nose tests, whatever function or whatever module you want to test, just give it that name, it will do the job for you. And if you want, I will write it here. So you have all of the information. Try to solve this problem using tests. So remember, this is the same approach I have been talking about all day. From morning I said, think about what are the corner cases, think about the function. Okay? And now once you are forced to write these kind of functions, you will write nice functions, because I can use this function now. Somebody else can call this function because it is well written. I can give it a string, it will give me the answer. I will give you an additional hint. What you present as the output of this frequency can be a dictionary. Use a dictionary, it will help you solve the problem much easier. What are you trying to do? You have to find the frequency. That means for every word, how many times is that word occurring in the string? Okay? You want everything to be lowercase, so convert the string to lowercase. One more hint. Use your good old split and all of the other functions you know in strings, and just check for every word. It's very simple. Use a dictionary to keep track, return the dictionary. Writing the test for this is a little more involved, but it's a good exercise because you will be forced to think, oh, how do I write this function? How do I make sure it is correct? So I'll give you 15 minutes. Please try to do this. Okay, so I've given you plenty of time to write this. Now let me quickly run through the solution. Okay, and I will make the solution available to you also. So first thing we need to check is, I need some test data. So let me give some simple sentence. Some text is A, B, C, A, D, E. We don't even need so much. So I'll see A, B, or A, B, C, A, B, A. So now we know the answers. I know exactly what frequency I should get. So I'll say result is word freak txt assert result. So I'll use a dictionary. Okay, this is something I've left as a choice to you. I'll make sure that result of A should be 3. And finally, I don't want it to be finding some random words. I know there are only 3 words in this, so the length of this dictionary should only be 3. So assert len result should be 3. Now obviously this is going to fail if I run it, because I have not written an implementation. Let me start writing out the implementation. So first thing I'll do is lower the case. Now notice that none of my test cases here worried about the case. So I'll change the test case also, so as to make sure I'm not missing out on uppercase and lowercase. That mistake is not being made. Okay. Now I need to count. So I'll say the result is a dictionary. Words is lower text dot split correct? Now what should I do? I have to look at every word, check if it has occurred or not, keep track and do counting. So I do a for loop. For word in words, result of word. Now the problem comes. If there is a result, initially dictionary is empty, I don't know what word is there. So what I will do is, if word in result of word should be incremented by 1. Else, what does that mean? It means the word is not yet there in the dictionary. Correct? So what should I do now? Result of word equals 1. That's it. So let me go over the code. Before that, I'll run it once. Passed. So my first implementation is correct, and I know it is correct up to this point. Now obviously I can make this more and more complicated, add more test cases, give it more meaningful text, put new lines, add more space, put comma, all of this nonsense I can do. But I know that this basic test will always pass, should always pass, because I have written a test case for it. I will go over the code once more so that you are able to follow. I simply take word frequency, I have written the function that is already done, I convert it to lowercase, I create an empty dictionary, okay. Then I iterate over every word in my input, all of them are lowercase, so I don't have to worry. If the word is already there, or okay, let's consider the case if the word is not there in the dictionary. The word is not there in dictionary, I will set, I have found one word now, so I will create an index in the dictionary saying result of that word equals 1. So count is set to 1. Next time if it is found, word is there in result, I will simply increment the count. Finished. And now I return result. So as you can see, writing a solution in Python is extremely simple. In 5 lines or 6 lines of code, I have been able to write out a clean solution, and better yet, in 5 lines of code I have written a test case which at one level even documents my code. Because now I know how to call this, I know what arguments to expect, and I know that my function is performing as per specification. And it is very easy to add additional tests. I could create, either I could create one more function, okay, if I want to, or I can just add more cases here itself. Add some new line, okay, cut, paste, copy this and say, okay, this is another test with more complicated data. So it is up to you on how you want to test it, but the idea is you have a test with which you can precisely identify where the problem is. Okay, one good strategy to use is to make sure that the tests are precise, okay, that they address a specific case so that you are able to debug the problem easily. And as you saw, the test passes very nicely, which means our implementation is correct. So I will make this code available to you, and I urge you to experiment and try out and learn how to follow this workflow, that is of writing good tests and writing functions that are reusable. One thing you will notice is all the code I have written here is reusable because I have designed it such. If it was not reusable, I cannot even write a test, right? So in this case, I have written a function for which I can give some input, get back some output, and I can test that output. Which means if somebody else wants to use this function, the same holds for him. He can import my code, call the function, give it input, it will give him back output. If I had written the same thing with print statements instead, no one can test it because nothing is returned, it is only printed to screen and I have to manually inspect to check correctness. So does this make sense? So it is a strategy you should follow, and it is a good practice for you to make sure that you are able to test as much as possible, and it is not always easy. sometimes you have to break your head, but it is worth the effort, because your code becomes immediately, the quality level of your code has improved, because you have put in that much more effort and thought into your programming, and ultimately that is what matters. So, what I will do now is we will stop with this today.